Hey everybody, are you ready? You have a test on Monday. You will have 60 minutes to take your test on Monday, so make sure that when you get set up to take your test, that you have a designated 60 minutes to sit and do it. Not that you'll need that amount of time, but that's the time that's allotted for you. All right, let's go ahead and get started with your review. All right, so our first two examples are just going from a rational exponent, so those are the fractional exponents, into radical form. So remember, the flower always grows above ground and the root of the flower is underneath. So the power will be the flower part, that'll be the numerator, and the root or the index, whatever root you're taking, is going to be from your denominator. So in order to rewrite 5 into the 1/4, the entire thing is in parentheses. So that means I'm going to take the 4th root of the entire quantity, 5n, and raise it to the first power. You don't have to put the first power there, but I just wanted you guys to see that. It can also be written how they have it, how you see a couple of other examples where the parentheses are on the outside and the power is outside of your parentheses. So number 1 should be D. Okay, number 2, we have to check, make sure that you have that common denominator, which is going to be the same thing as the root of the example. So in both of these, we're going to take the 4th root. So I will take the 4th root of, since they have different powers for each of these, I'm going to write them separately. So I'll write x to the 3rd times y to the 1st, or 4th root x cubed y. So that one has an answer choice of D as well. Please double check me as we're going through. So if I make a mistake, by all means call me out on it. Let me know so I can go back and fix it and let everybody know. I'll try not to make any mistakes. All right, this time we're going back into exponential form. So whatever is inside the radical's little hook, that is your root. Whatever you have inside up here, under the root, will be the power. So the entire term 2b is under the radical, so that would be 2b to the power of the power over the root, so to the power of 6 over 5. So 2b to the 6th fifths should be example 3's answer. For number 4, again, both terms are under the radical, so I'm going to write those in parentheses. I'm going to raise them to the power of 4 over, over the root of 3. So it's going to be to the power of 4/3. You could separate those out, but none of our answer choices are, so let's just keep it like it is. There we go, 5k to the 4/3 power. In examples 5, 6, and 7, you are going to simplify, so you've got to remember some of your properties of exponents, as well as what does that rational exponent actually mean to do. So if I distribute this to every single term, that's the power to power property, that would give me 16 to the power of 1/2. A 2 times 1/2 would be 2 halves. I'll show you the long way. You can reduce them in a smidge. And then B to the power of 4 times 1/2 would be 4 halves. So remember, 16 to the 1/2, we just rewrote those a second ago. That actually means the second or the square root of 16 to the 1st. So the square root of 16 is 4. A to the power of 2 over 2 would just give me A to the 1st. And b to the power of 4 over 2 would give me b to the 2nd. Okay, so example 5, answer choice A is correct. We're going to do the same thing for number 6. Distribute that property. Power property gets multiplied to everything. So that becomes 64 to the 1/3. And then P, 6 times 1/3 would be to the power of 6/3. So 64 to the 1/3 means what is the cubed root of 64? Which is 4, and then p to the 6/3, 6 divided by 3 gives me 2, so it's p squared. So 4p squared is our answer for number 6. And then our last example, This is the product property, so I'm going to multiply the coefficients together first. So 3 times 3, you can rearrange these however you want. And then n squared times n to the 5/3. So 3 times 3 is 9, and then n squared n to the 5/3. Okay, right now, since I have multiple choice, I'm going to go through and cross off the answers I know are definitely not going to work. So I have to figure out, does n to the second and n to the 5/3 equal 11/3 or 4? So let's simplify through. So we're going to get a common denominator, so an LCD. So a power of 2 would be the same thing as 2 over 1. I need that to become something over 3 so I can have the same denominator as the other term. So 1 times 3 is 3, so 2 times 3 is 6, which means I can write the n squared as n to the 6/3 power. And then I'll keep all my other terms the same. And then last but not least, now that both of the n's have the same root for that rational exponent, I can keep the base of n and add those two exponents together. So my coefficient of 9 stays the same, and then it would be n to the 11/3 as your final answer. There you go. That's answer choice A. Multiple choice, guys, always, always, always reduce any examples. Get rid of anything that doesn't work. Give yourself a better chance. All right, a few more properties of exponents. In this case, we're dealing with the quotient property because we have a division symbol. So that means we are going to subtract the exponents, but we have to take care of the negatives first. So anytime you see a negative exponent, then it's either going to move up or it's going to move down, depending on where it was negative to begin with. So in this example, x squared over x to the negative second, y to the negative second, both of the terms in the denominator have negative exponents. So to make them positive, I'm writing their reciprocal, I'm flipping them. So the x squared stays, that's this guy. I'm going to put the other ones in the other color so you'll know what I'm doing. And that would all be over 1 so far. So the x to the negative second is going to come in the numerator. Y to the negative second will also move up to the numerator. So now everything's just over 1. And I can use that product property. X squared times x squared would give me x to the 4th times the y squared already there, all over 1, which is give me answer choice C. There we go. In example 9, we are back to the power property. And you've got to be careful with your coefficients that you have. They have to get multiplied through as well. Don't forget, we showed them just a minute ago. And here's another goof that we tend to do. Negative 4 to the second, that actually means negative 4 times itself twice. So if you're typing that in the calculator to get a positive 16, make sure that you put that negative 4 squared in parentheses. And then that will give you the positive 16. Then I have v to the negative 3rd raised to the 2nd power, so negative 3 times 2 would be v to the negative 6th. So now I have 16 v to the negative 6th, and that v to the negative 6 has a negative exponent, so we're going to flip or write the reciprocal of that term, put it in the denominator, so that I can make it positive and get the final solution of 16 over v to the positive 6th, which is A. All right, number 10. Definitely double check your work with taking your square root or taking a cubed root. Remember, the square root button you have on your calculator, check, you got it. In order to get the cubed root symbol, you have to press 3 and then the second button, and then the little caret button, the little up button, and that will give you the 3 inside your hook. It'll put it a little box blinking right there to start with. All right, so what root are we doing for number 10? We are taking the square root or the second root. If you want to test it in your calculator, you can go ahead and put the square root of 128. It will simplify that part of it for you. It will not do the square root of the p squared, okay? Just to show you, 128, that is the same thing as 4, let's see, 4 goes into that because I know 4 is a perfect square 32 times. So that's 4 times 32. I can also break down 32 to be 4 times 8. And then I can break down 8 to be 4 times 2. So each of these 4s, I can take the square root of them because those all break down to be prime factors as 2 times 2. So the square root of 128 is 2 times 2 times 2, those are the red ones, times the square root of 2, or 8 square root 2. So you can type that in your calculator and check it. The square root of p squared, you guys should remember a square root and a square, if they're identical, will undo each other. That will just give you p. So your final answer should be 8, p on the outside, square root of 2 underneath your radical. Kind of a weird way to look at that, but sorry, it's just kind of how I wrote that one. If you need more of those to practice, let me know. You've got a ton on some other worksheet, B, I think it was, from a long time ago. Or I can send you some if you think you need them. All right, into solving. Yay for solving. All right, so we're looking, do we have two radicals equaling each other? Check, check. So in that case, as long as they have the same root or the same index, then you can raise them both to the same power. If they don't, which you're not going to have, then you'd have a lot more work. The other option is if we have one radical equaling just a number. We'll see a couple of those. And I think we're even going to see two radicals with extra terms in there just for a few more. And remember, those guys are a little bit more of a challenge. They're not the hardest ones, but they are a smidge more of a challenge on that set. All right, so in example 11, we're going to solve the square root of 2n plus 2 equaling the square root of 3n minus 2. So in order to do the square root, I need to raise that entire thing to the second power, and I'm doing that on both sides of my equation, kind of saving space. So the square root and the square undo each other, leaving me with a 2n plus 2, equaling the square root and the square on the other equation undo each other, leaving me with a 3n minus 2. So now we're going to solve for n by combining like terms. So I'm going to subtract n on both sides, and then I'll also go ahead and add the 2 so that I can reduce those. And when we finish, we'll end up with 4 equaling n. Perfect, love it. So that is an answer choice. Because we only got one answer, and there aren't any on here that say no solution, you can bet that this one does work. But just to make sure, we're going to check. So is the square root of, let's see, 2 times 4, 8 plus 2 equal to the square root of 3 times 4, which is 12 minus 2. So does the square root of 12, or excuse me, square root of 10 equal to the square root of 10? Heck yeah, sure does. Fabulous, we were right. Another test taking strategy, if you totally 100% forget, by all means, a friend of mine calls it back solve, but I call substituting in. So substitute in any of the answers to see which ones give you the correct solutions. There you go. All right, in example 12, this problem is written two different ways. We do only have one radical in the equation, which we're going to isolate. And then the other way that it's written is in rational form. And I'm going to show you the problem both ways to show you it doesn't really matter. You can still solve it. All right, so if we're dealing in radical form, 2 equaling the square root of -1 minus k. So my radical is isolated, meaning it's all by itself. If it's the second root, then I have to raise it to the second power to undo those two things. So I will do that to both sides of the equation. That's going to leave me with 4 equaling the square root and the square undo each other. So 4 equals -1 minus k. I'm going to go ahead and add 1 to both sides of the equation. So 5 equals, be careful, don't forget your sign, -k, which means that k has to equal -5. Okay, so a quick check to make sure that that works. That is an answer choice, so it should work. It's also in another one too, so we just want to make sure we didn't get two solutions. When we double check, 2 equals, does that equal the square root of -1 minus -5? Minus negative becomes plus. So does 2 equal the square root of 4? Yeah, 2 definitely equals 2. You got it. Remember, we're only looking for positive solutions for these when we take our square roots at the end. All right, showing you the other method. If it's written in radical form, you can, or I'm sorry, rational exponent. That one, whoops. Rational exponent. So if it's written in this form, you can convert it back to radical. That's one option. Another option is to actually take whatever the power is and multiply that power or raise it to its reciprocal. I'll show you why. Sounds funny. We didn't practice a lot, but here we go. If I raise that entire term, -1 minus k to the power of 1/2, if I raise it to the power of 2 over 1, or just to the power of 2, and again, I would do that on both sides of the equation. Check real quick. 1/2 times 2 over 1 gives me 2 over 2, which equals 1. So those undo each other. So when you multiply by its reciprocal, it's a multiplicative inverse, so it undoes itself. Big words. I'm throwing out some big words today, y'all. I'm just feeling the big words. Here we go. All right, so 2 squared equals 4. That leaves me with -1 minus k. And lo and behold, look, this is 100% identical to what we had in step 2 on the other side. So as long as you don't make any silly mistakes, you'll get the same solution. And the value k equaling -5 does work. Yay, us. All right, we are still not halfway through with these, and I've been taking a while, so it's going to be a long video. Sorry. All right, number 13. Again, if your brain falls out and you forget, by all means, substitute back in. In this example, we've got r minus 5 equaling the square root of 3r minus 17. That is a square root, so I'm going to raise both sides to the power of 2 to undo it. You have a binomial, 2 terms on the left-hand side. So that means r minus 5, that quantity squared, that means r minus 5 times itself. And you are going to either box or FOIL, whichever method you like, to multiply those two things together. So I'm going to skip that step, let you guys do that work and check it on your own. You should have r squared minus 10r plus 25 equals the square root and the square for the other side of the equation undo, so that all just equals 3r minus 17. Lo and behold, you better set all this stuff equal to 0 so that you can factor. So we're going to subtract 3r on both sides of the equation, and we will also add 17 to both sides of the equation. See how this mess works out. Our whole goal is to set it all equal to 0. So I have r squared, -10 minus 3, so that means I borrowed 10 and then I borrowed 3 more, so that's -13r. And 25 plus 17 will give me a positive 42. That all equals 0. We're going to do our little diamond problem off to the side. What multiplies to 42? So that's 1 times the 42, but adds to a -13. -6 and -7, put your little r's over top, and those become your two factors. So in this example, when we set our two factors individually equal to 0, we are going to get that r minus 6 equaling 0, so we'll get r to equal positive 6, and r minus 7 equals 0, then we'll get r equals positive 7. So if you notice, I have an answer choice with both 6 and 7, and then I have an answer choice with only the 7. I know it can't be the other two because it doesn't equal -6 and it doesn't equal -7. So I'm down to a 50-50 shot. This is why you have to double check your solutions. All right, so let's check. Does 6 work? That's the only one I really have to check. I know that 7 works. All the answers had a 7 in them. Boom. So I know that that guy's good. Shortcut. I mean, you're being efficient. So let's check R equaling 6. So 6 minus 5, does that equal the square root of 3 times 6 minus 17? 6 minus 5 is 1. Does that equal the square root of 6 times 3 is 18 minus 17? Does 1 equal the square root of 1? Yes, it sure does. Boom. So that means our answer choice has to be A. Both solutions work. You can have solutions that don't work, so there was a possibility that the only answer that would have worked would have been C. All right, now we're on to solving with the rational exponents. I showed you one a moment ago in example 11, I think. Maybe it was 12, I forget. So this shouldn't be too bad for us. In example 14, we are going to first add 2 to both sides of our equation. So when I bring it down, I'll have 6 equaling the quantity of x plus 28 to the 1/2. Again, you can either rewrite that in radical form, or you can raise it to the power, flip it upside down, of its reciprocal. So you're going to raise everything to the second power. You would do that anyways if you changed it to radical form. All right, so 6 squared is 36, and x plus 28 to the 1/2 squared just gives me an x plus 28. Subtract 28 on both sides of your equation, and solve just to get x equaling 8. There we go. So that's only answer choice D. Again, if it doesn't say no solution as an answer choice, I know that what I get has to work. I love that. Less work for me. All right, in number 15, 1 equals 2 times the quantity of a plus 20 to the 1/3. That means the cubed root, and all of that is in minus 5. So I'm going to add 5 to both sides of the equation first. Bring that bad boy down so I got a little bit more space to work. So 6 equals 2 times the quantity of a plus 20 to the 1/3. The radical is not isolated. You've got to divide through by 2 first. So isolate, isolate, isolate. Kind of like you're doing now. We're all at home. All right, so 6 divided by 2 is 3. That gives me the quantity of a plus 20 to the 1/3 power. Just like we did in the last example, we're going to raise everything to the power of the reciprocal of 1/3, or 3 over 1, or just to the 3rd power. If it was the cubed root, you'd raise it to the 3rd. Again, same stuff. So those guys will undo each other, thank goodness. And I have 3 to the 3rd. 3 times 3 times 3 is 27. That equals just a lonely a plus 20. When you subtract 20 from both sides of your equation, you should get a equaling 7. And I do. And it's the only choice that has a 7. Nice. They're making this too easy for us, gang. Too easy. Okay, so now we have the same word problem to answer several different questions with. This one kind of hits home a little bit, so hopefully it doesn't stress you out or offend you or anything. I didn't write this problem, somebody else did. All right, so on a tiny little island out in the South Pacific, they're studying the effectiveness of the flu vaccine. Here's a function which represents the relationship between T for time, from the day you get the flu shot, and E, the effectiveness of the flu shot in fighting off the flu. So your equation is E, the effectiveness, equals -2 times the square root of T minus 3, so time, your number of days from you get your flu shot minus 3, plus 6. All right, according to this formula, for number 16, what will be the level of quote-unquote effectiveness after 3 days? Okay, so what were they represented by in the equation? Are they T for time or are they E for effectiveness? Ding, 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 T for time. So you are straight up going to find the effectiveness level by substituting in a 3 for the T under your radical. That's it. Now simplify. Do everything in parentheses and radicals, exponents, do all that stuff first. So 3 minus 3 is 0. Okay, cool. What's the square root of 0? 0, duh. What's negative 2 times 0? 0. What's 0 plus 6? 6. So after 3 days, the effectiveness has a level of 6. Now, I don't really know what that means, but it answers the question. Okay. So in number 17, same type of question. According to the formula, what's the effectiveness after 7 days? Okay, so think for a second. Do you think it's going to be more? How many of you think more? Let me know. Raise your hand. Question mark, question mark. How many of you think less effective? Question mark, and why? What would you look at to know? And you're thinking, Fairbanks, we don't care. Just tell us how to do the stinking work. All right, here we go. I'll make the connection in a second. Somebody wanted to know, I'm sure. All right, so again, I'm going to put in T as 7 in this case, so my effectiveness level is negative 2 times the square root of 7 minus 3 plus 6. 7 minus 3 is 4. The square root of 4 is 2. So negative 2 times 2 plus 6. That would give me a negative 4 plus 6, which gives me 2. So after 7 days, now my effectiveness of the vaccine has decreased. Anybody have an idea why? What in your equation could tell you that? Yep, you guessed it. You guys are so smart. I love smart kids. That's the only kind of kids I teach. Smart kids. So the negative in the front, that means that your entire function is going to decrease as you travel from the left side of the graph to the right hand side. It's a negative. It flips it upside down, or it has that x-axis reflection. So we're getting to that. That's another question in a minute. All right, same question, Tiny Island, talking about effectiveness of the flu shot. Oh, hey, here's the question. According to the formula, what are the transformations from the original square root function? So the OG is y equals the square root of x. Okay, so what are all the different things that we have? These are transformations. The last lesson you guys did Monday or Tuesday of this week, I believe. So that a value in the front is both negative and a 2. So the negative means that it reflects the x-axis, but the 2 tells you that it's going to have a vertical stretch. So that means it's either going to increase or decrease twice as fast. Vertical stretch of 2. There we go. All right, our next little part inside parentheses, that's always going to do the opposite every single time. So if you see t minus 3, that's actually traveling to the right 3 units. And then last but not least, our y value at the very end, that tells us if we're going to shift up 6 or down 6. Since it's positive, we are going up. All right, so I'm going to work backwards. Up 6, up 6, up 6, up 6. Okay, didn't change any of those. Left 3. Nope, it said right 3. So this guy is gone. Right 3, right 3. Okay, so next thing I need to look at is reflex and vertical stretch of 2. All right, so I've marked off D because of that guy. I can mark off answer choice B because it doesn't have the reflection. So did we have a vertical stretch of 2 or a vertical shrink of 2? Ding, ding, ding. We had a vertical stretch of 2. Answer choice A. Reflex x-axis, vertical stretch of 2. Both come from the coefficient in the front. Right 3 and up 6. I spent a lot of time on that one. Sorry. Eek. All right, these are a little tiny to see, but we'll figure them out. So in this one, it's asking us interpret what the actual function means as far as your vertical stretch or shrink and reflection, the time of days, and what's going to happen to your graph over time. I chopped off part of the question, so I'm kind of going off the cuff on that guy. So our answer choices are, the vaccine takes 3 days to have any effectiveness, and then the level will drop off over time. Okay, so remember, that negative in the front tells us that our graph is going to decrease. It should look like example A or example C. So anything that says it increases over time is wrong because that A value is not positive. All right, so now we need to determine which one is the better answer choice. Does it take 3 days to have an effect? Or does it take 6 days to have an effect? The graph is the exact same. They're both at the 0.36 for this, like that critical point, or kind of like a vertical or a vertex point. But remember, the time was what's represented underneath the radical. That is going to give you your domain, which is your next question. So we'll do kind of 2 in 1. When you set that equal to 0, so t minus 3 equaling 0, and solve for the domain, that tells you when the effectiveness is actually going to start. So on the 3rd day, after 3 days, answer choice A is our domain. That's when it starts to work. After 3 days, then it kind of starts to decrease. All right, and then numbers 20 and 21, we've actually already answered number 20 because it says, what is the domain? So we already have our graph. It was at the 0.36, and that was that critical point, and then it sloped down and over to the right. So our domain, we are looking at only the x's. So our x-axis, it starts at 3 and goes on and on and on and on forever. It is an included point, so technically this answer choice for B should have a bracket. I promise you on your test, I made them have brackets when they needed. So any of these should actually have brackets on them. That's okay, it happens. So 3 days and up should work. Your range comes from the back end. That's your y value, your vertical shift up or down. So your range is going to go up to, in this case, that particular y value. So my y's are traveling from this negative y value up to and stopping at y equaling 6. So the last value for my range has to be positive 6 and has to be included, which again is answer choice B. Okay, we're done with those. Okay, great, fabulous. Only a few more. Find domain and range. You have not only the equation, but you also have the graph. So if you're looking at your graph, my domain starts at this x value and travels forever and ever and ever and ever and ever to the right. So that starts at 4, which comes from underneath your radical, out to positive infinity. Should have a bracket like answer choice D. Don't get confused with C. And then our next one, for the range of the function, the y value for that critical point is at 1, and then it travels up, 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 up. So my y values are traveling up. So that range should be from y equaling 1 up to positive infinity. And again, it is an included value, so it needs to have a bracket. Numbers 24 and 25 talk about intervals of increase and decrease. Okay, so again, you can look at that leading coefficient. If your a value is positive for square root functions, it's going to increase. If your a value is negative, it's going to decrease. That's actually true for any function, but it's really easy to see for the square root functions. So in this case, it is definitely increasing, and you use the domain where you use your x's for your interval of increase or decrease. So whatever your domain was, I can't go back to it, but it is from this x value 4 out to positive infinity. So that should be answer choice A for domain, or excuse me, interval of increase. I was looking at that. And your interval of decrease, does it ever fall down? Heck no. So there's none or no interval of decrease. Yay guys, we're almost done. I know I'm hitting like 35 minutes. This is a long day, I'm sorry. All right, 26 and 27, same equation. Thank goodness. We are going to look at the left side and the right side end behavior individually. On your test, it will be written as one answer. It'll say left with the answer, and then it'll say right underneath it with the answer. And there should be plenty of space in there that you guys can actually read your different answer choices. So as my x's go to the left, so I'm traveling to the left, I can only go to this x value at 4. So it has to stop there. So as x approaches 4, what do the y values do? Well, in this case, my y values, traveling from the left, reading backwards, are falling down. So the y values approach, not negative infinity even, they approach that y value of 1, because that critical point that we started with is the 0.41. So be careful in your answers. I almost selected A, but that back end solution is wrong. It should say as x approaches 4, f of x or y approaches positive 1. Okay, that's the left-hand side. On the right-hand side, so now I'm starting at my regular point. I'm traveling to the right. So as x's go on and on and on and on to infinity, my y values travel on and on and on and on and up to infinity. So as I go to the right, so I can't use answer choice C, that's a no-go. So as I go to positive infinity towards the right, the y values, yeah, they go to 14 and 12, but they go past it for sure. So answer choice B works for number 27. All right, transformations based upon pictures. On your test on Monday, the pictures will be different colors, and it'll say based upon the square root function in blue or red or whatever color it is. So our square root function is the one down at the bottom. That's our regular parent function. How did we get the original function to the other one? Okay, so did it go up? Did it go down? Did it go left? Did it go right? Which way did it travel? So I'm just going to start from the origin at 0, 0 and travel. I'm going to go to the right 2. Okay, so that says left 2 gone, left 2 gone. Okay, left 5 gone. Oh, okay, well that was easy. I traveled to the right 2, and then I travel up 5. So we are at the point 2, positive 5. There is only one answer choice that says right 2, up 5. There's only one answer choice that says right. Tricky, tricky. All right, so this next one is a cube root function. So the cubed root, oopsie, of x equals y, my bad. Don't forget, guys, these have domain and range from negative infinity to positive infinity, and they will either only increase or decrease, so that's kind of nice. These have a critical point right smack dab in the middle. So the parent function is going to be at 0, 0 again for its critical point, and I'm going to travel to see how I'm getting to the new critical point where I see that curve in there. There aren't any vertical stretches or shrinks or reflections, so I should be good to go. So to get from 0, 0 to this point of 3, 4, we have to travel to the right 3 and up 4. So right 3, up 4. Cool. Answer choice A. Awesome. We're almost done. 2 more. Here we go. All right, now you have it in an equation. Dagnabbit. So we're going to look for A values at the beginning. We are going to look for horizontal shifts under the radical, and then we will look for our vertical shifts outside of the radical added on to the back end. So in example 30, the square root of x is the parent function, f of x, and our transformed g of x is -5 times the square root of x plus 3, and then -7. So then I see a reflect for every single one. I can't cross anything off. So that's the negative, does the reflecting. The 5 is a vertical stretch. Don't get bogged down by that. It is not a shrink, so it can't be C, and it's not a stretch of 4. That's the goof up in answer choice D. So right now A and B are good. Reflect, stretch, vertical stretch by 5. Okay, so now you have to decide, does it go left 3 or down 3? So the x plus 3, remember, do the opposite. It says you are going to travel left 3. So answer choice A is correct. And then our last part, the -7, that does mean to travel down 7. Okay, last but not least, cubed root of x is our parent function. 3 times the cubed root of x plus 1 minus 4 is our transformed function. What does the a value in the front tell you? No reflection, so is it a stretch or a shrink? Greater than 1, so it's definitely a stretch. So right now we can cross off answer choice B. As you go through, like, cross off what you can, guys. They all say stretch by a factor of 3, so no other typos that I can't get rid of. Just like our last example, under the radical, do the opposite. Remember, if it's, so we could solve for that and we would get x equaling -1. So we're going to travel to the left 1. Answer choice A says left 4. Answer choice C says right 1. We've already crossed off B. That one was gone. So we don't even have to check the last one. We know what it is. It definitely does go down 4, but answer choice D is our correct solution. There you go. All right, kiddos, that is everything that you could see on your test on Monday. If you need any other help at all, please reach out to me. I don't mind to pop on and do a Google Meet with you anytime on Friday as needed. And as long as you're not taking the test, I don't mind to answer a couple of questions if you have any before you start the test. But remember, I created the test, so I know all of the questions, so you can't throw one at me that I'm going to be like, oh yeah, I'm not sure. No, I'll know if it's on there or not. Hope you guys have a good day. Continue reviewing. Enjoy your fabulous weekend, or hope you have enjoyed it if you're watching this later. Good luck on your test. Miss you guys, and I'll see you in late April, hopefully. Bye.